Okay, our final panel of the day. Thank you all for sticking around. This is going to be a really great conversation. I want to dive right into it. Let's just go down the line and do a quick intro, a little bit about yourself and a little bit about your project, and let's go from there.
My name is Greg Osuri. I am an open source developer and a core contributor to Akash network. Akash is the world's first decentralized supercloud. The superpowers come by tapping into underutilized resources, and particularly GPUs, which are very hard to come by. We're powering the most important technological paradigm shift humanity is facing, called AI.
I'm Dean Tribble. I'm CEO of Agoric and a technical founder. I first got into software many, many moons ago in earlier generations of AI. And I am not a modern AI expert, but rather a consumer in some sense. Our chain is about coordinating the activities of lots of other chains, so you can build multi-chain applications, but that kind of middleware AI is getting really good at faster than many other areas, and so that will be enhanced in the next couple of years very much by AI. So I'm a consumer of that technology, and also a board member of the Foresight Institute, which has had a long program in AI safety. And so a lot of what we build and how we think about it is how do you lay down the rails so that AIs can be safe and how they can cooperate with us and with each other in a productive way.
Hello all. My name is Valery. I am a physicist and I'm co-founder of Cyber Protocol, where we are building a decentralized AI stack. And with community, we are building bootloader to bootload superintelligence. We are from very beginning in the Cosmos industry, and we love Cosmos and all you guys.
Yep. Hi, I'm Murthy, co-founder at Vitwit, and building Arka network. Arka network is a AI execution layer and agent platform. Anyone, if they have AI model, they can bring onto Arka network, integrate with any protocol. Yeah.
So I'd love to dive in with a general question. I'd love to hear all of your takes on it. Just to get us started with the topic, we're talking AI and Cosmos, so I'd like to set the stage and obviously tie it back to Cosmos. What makes the Cosmos uniquely attractive for decentralized AI development? Greg, let's start with you and then go down the line.
Cosmos is in my opinion, the only layer 1 app chain framework that works without an issue. Akash is a prime example. We've been live for about 4 years, and we haven't had a single unplanned outage. So that there is that proof in the pudding, and we grew pretty massively, right? We grew our usage, we're maybe by order of magnitude every year, and so far it's testing its limits, in decentralization is so early, especially infrastructure decentralization, you cannot afford to have congestion issues, you cannot afford to have faults like you experience with other chains, in particular Solana, where, I don't know how many of you use Helium, but, you try to, I love Helium, big user, big fan, whatnot, but they do have several issues where you're trying to, claim tokens or even, I think, the failure rate is, the phase of decentralization. And we haven't solved the scale part of decentralization yet. So until the scale is solved, sovereignty is super critical. Even when you solve the scale, I think sovereignty will have its own trade-offs, which in a way is advantageous for decentralized physical infrastructure networks. So I think there's a lot less attention that Cosmos gets when it comes to deep-in networks, and Akash being one of the biggest deep-in networks is a testament to the technology.
And as he says, Cosmos is the place where you have sovereign systems communicating with each other. Other chains have been forced into that. That's the reality of the world, but they wanted to pretend it was a much simpler place. And Cosmos took that head on. And so you've got the idea of independent things cooperating with each other. That's the framework in which an economy is built. That's the framework into which AIs need to be embedded. And so, there isn't going to be one AI. There's going to be a bunch that talk to each other. And that's just the mindset you need to have. And Cosmos is the place where that starts.
In my opinion, the main thing is IBC, because it allows us to connect all possible computers and projects together. And Cosmoverse virtual machine allow us to define protocols to transfer data between chains. And AI projects, this field is pretty huge. It relates to AI agents, data curation, and incentives for data. And all this is pretty complex, big parts, but we can split them in modules. And all these modules can be pretty easy implemented using smart contracts, and Cosmoverse virtual machine is very fast and super functional. And with the power of IBC, we can connect all our projects together and bring power and all our features, communities together to build real smart AI.
Great. So already Greg and Dean told sovereignty, and just now we heard about interoperability, right? So there is a different question to me all the time. So why you're building Arka network as a sovereign chain? You can be a roll-up on already existing L2s, right? So my answer is this. There was a specific use case we were trying to build Arka. Let's say now we have a quest going on Polychain, right? People are betting on who will win, right? See, the chain, Polychain is a marketplace, right? If that chain worth is very less comparing to the people who bet on that particular option, right? So now the underlying chain has to be, this is one reason. And the another reason is, let's say if you wanted to build an AI agent to solve the resolution for that particular option, there is a cumbersome governance. If AI agent is going to solve that, we need to run the same AI model that scrape metadata and internet data and finally converge. Okay, so this guy won. And now everyone will accept that. That means AI agents transparently, they will be concluded in a consensus way that so someone is won in that particular option, and the smart contract will do its job, like distribute who won, who lost it. So this requires sovereignty, right? So maybe instead of asking someone else, we can ask our validators to run the same AI model. The output of AI model will be put into consensus, whatever that comes. It is verifiable, right? So this is the reason why we wanted to build, as a app chain. I think Cosmos is the place, everyone builds sovereign chains. Yeah.
So moving right along, I have a question for each of you that tackles each part of the AI stack that you need for decentralized AI development. Greg, I'd love to start with you. What do you see as the current state of open source AI, and why is permissionless compute crucial to enabling decentralized and democratized AI development?
So the open source AI is maybe 2 to 3 months away from catching up to closed source AI. It's very good. In some cases, like Llama 3.1, which is a 405 billion parameter model, exceeds the quality of closed source AI, right? So and some of the open source, like smaller models, are significantly better than some of the closed source smaller models. So, but this Meta model was developed by Meta, which is a closed company. So that brings to the decentralized training. The Meta 405B took about 30,000 H100s, and I think it cost about $100 million. If I'm not wrong, I can't really quite compute the actual cost. But that also tells you that it is expensive to train these models. And Meta generously open source the models, but the question about whether they're going to open source the next model is still unanswered. So that brings to decentralized training. Can we actually create truly decentralized systems that are trained on decentralized compute networks? And the answer is yes, we can. So the first example we saw was a billion parameter model by News Research, trained truly on distributed GPUs, so reliant on co-located GPUs that are interconnected with high bandwidth. That means you need lots of compute packed into very small places, right? That was a notion. But that changed with News' framework called Distro, which actually leverages internet, that means low bandwidth environments to actually train models. And number two, we saw with the companies like Prime Intellect training a 10 billion parameter model, which is a significant development, because quickly, within about 2 weeks, we saw this quick jump, and now they've completed about 15% of the training. They should be completing the rest of the training in a couple of weeks. And by the way, both these models are being trained on Akash, which is an incredible point, because Akash gives access to the decentralized compute resources to train decentralized AIs, right? So, and the next step, obviously, is a 100 billion parameter model and a 1,000 billion parameter model. To give you an idea of the kind of compute it takes, GPT-3, I believe, took about GPT-4 was trained on a 10 megawatt data center, which is not easy to get, but it's possible to get a 10 megawatt data center. Because the big challenge for training AI is not compute alone, it's actually power, right? It takes a lot of power. And it's growing at the rate of half an order of magnitude every year. So the next model, which is Grok 3, which is trained by our friend Elon Musk in Memphis data center, takes about 50 megawatts. And if you ask me where they got 50 megawatts, they're actually burning diesel. Because there's no single place to get 50 megawatt capacity. So the next model is going to be 250 megawatt, and a model after that is going to be 1.2 gigawatt. The only place to get a 1.2 gigawatt capacity is a nuclear reactor. So we're slowly getting to that point where we need lots of compute and lots of energy to power data centers. And that's, it takes, US has about approval for about 70 new nuclear reactors we can build. We just never built them because there was no need for them so far, except the AI came and literally taking all the power supply. So that's why it's important to decentralize and distribute computing power, and technologies like distro and technologies like Open Dialoco are actually very promising that can deliver these large LLM training. That comes to now, where does distributed compute and where does decentralized compute come into picture, is really when you look at the deployment of this compute, right? So since the GPU crunch last year, I don't know how many of you are familiar, it's highly impossible to get GPUs to do any meaningful AI last year, but that quantity is below 5,000 units to lots of players instead of selling lots of compute to a single player, because that works out better for the economics. They want more distributed compute. So now there's enormous amounts of compute spread across hundreds and hundreds of data centers across the world, and that really tells you that really brings about the need for a layer to connect these distributed data centers, and that layer cannot be centralized, right? I think that's critical for this layer to be decentralized, and Akash is one of the decentralized networks, if not the leading decentralized networks that's connecting these distributed data centers that are maybe 10 megawatts, 5 megawatts, and definitely not nuclear reactors, and we're seeing where the evolution is happening for these data centers too. Like if you think about where we can use sustainable energy to where that could, talking about solar panels on Earth, if you put a square mile of solar panels, we get about 2.2 gigawatt capacity, but it's very hard to cool them. But it's not continuous, so you need batteries to store the energy. And the challenge with batteries is cooling, right? You can't have so many batteries in desert that's super hot. So there's a notion now to create data centers. And also, another interesting development happening with bandwidth is satellite internet, right? So with Starlink, getting smaller and smaller, with Starlink Mobile actually getting to a point where devices are going to be powered by satellite internet. We're talking about mobile phones in next couple of years. So if you actually look at the trajectory where the technology is going, you're going to have direct satellite internet on mobile phones, where on the other side is going to be an AI that's streaming. Coming to the point.
Okay.
So
AI.
So where do you put the best place to get continuous solar power that doesn't require cooling, there's lots of self-cooling continuous data centers with 30% more efficiency and half the latency to power AI? Satellite data centers. So it's not too far in the future we're going to have data centers in space. And the question is, how does this data centers need to be networked? Is it going to be centralized or decentralized? I would bet on the decentralized. So it's a long way for decentralization to go, but it's a very exciting journey ahead. That's my long-ended answer as to why we need decentralization.
We got all the way to space data centers.
Space data centers are coming.
Dean, I'd love to move on to you.
Sure.
That's hard to follow space data centers, I know, but
Oh, I'll get there.
I don't doubt it. How does Agoric's orchestration platform enable AI development?
So partly it's sort of the overall architecture of as we talked about Cosmos and in generally crypto. You're saying you've got this models that's going to scale very much non-linearly. For that reason and also for privacy reasons, you're going to end up with lots of AIs that talk to each other, right? The so-called agentic systems, right? Where the medical diagnosis is $85 billion industry in 2023. It's got, and a big chunk of that is the information, right? I've got a doctor's office. They do some amount of diagnosis. They then want to bring in a heart specialist to do more diagnosis. In the AI context, the doctor has an AI that's doing their sort of family clinical practice, and it goes, I could use a specialist. You've got the specialist that has an AI that was trained on special data. They have a special model. Now you've got, I don't want you to keep the patient data and mine it for your next generation, but you also don't want to give me your model. Now you've got the structure of that market means you have privacy concerns and walls that make you want to have AI agents that are cooperating. And that's what an economy is like. That's what we're going to get to. That's all about more and more complex pieces that someone needs to go, okay, here's the scheduling, here's how you put all these things together, right? We've got trillions of dollars a day of, managed inside of microservices that are orchestrated by JavaScript at the backends, JavaScript in Bloomberg terminals, Salesforce, all these different systems. And AI is going to end up in the same thing. Now, so that's one dimension. The other dimension is, as I was saying earlier, middleware is more amenable to AI than normal programming is. People think, okay, AI is going to write all our programs, and they aren't as good as that as they appear to be right now. That same kind of thing where they can tell you a story that sounds true and just isn't. But for middleware, they do pretty well because that's so much more structured. It's about pulling together best practices. It's about staying within these guidelines. And so that's a place where AI contributing on the, here's what a user wants, can you generate me a strategy, is great. But the model they program to, where the strategy that the AI puts together, if it's in Solidity for a multi-block, multi-turn, thing that's going to happen over time, no one will understand it. If it's in Cosmoverse, no one will understand it. Because what you said, do this, then every day do that, gets the expression of it in a program doesn't look anything like what the human thought they were going to get. And with the right framework, which is what a lot of the orchestration is about, the sequence of do this, then do that, then wait for that, and do that other thing, is kind of what the program looks like. So you might not be able to write it, you might not be able to create it, but an AI can create it, and a human can understand it. And a human can go, no, that's not quite what I meant, let me adjust it a little bit. And so that's a very important thing, is to have the infrastructure we're building on have the rules and the rails that we infrastructure guarantee that I don't care what I'm doing for you, it can't get at my account, right? I'm not counting on the code that the AI generates for you to protect it from my account. What I want is your code runs in a box that doesn't have access to my account. And if I want to have an AI program that shares something with you, we'll be clear about that. And that's so that's, again, the system and framework into which you embed AIs is critical. Orchestration is a big part of how do we build a system and framework such that humans, blockchains, programs, and AIs can all cooperate productively.
So we're laying out the space. We have compute, we have orchestration. Valery, I'd love to move on to you. Talk a little bit about distributed training, which is obviously very important. It's a crucial piece. It's evolving at the moment. How do you see distributed training of AI models leveraging the Cosmos today? And what are the next big unlocks to see truly effective and efficient distributed training?
Thank you. Absolutely great story, and Greg mentioned about prime intelligence. And this is amazing achievement for open source community. And I was really surprised when the guys released the code, and said that 10 billion model was trained, distributed. But the interesting thing is that research on distributed training is going in from two separate ways. So we have open source community who would like to train their own models at homes, using small clusters connected, and from tech giants who cannot bring they can bring a lot of compute in one place, but they cannot bring energy in one place. So they need to distribute, connect different clusters in different states where they have needed energy. So they also need to solve distributed training issues and researches, how to reduce bandwidth needed to transfer all these gradients and other things. Same direction as open source community do this. And this is just started field, and my team, we would like to also experiment with Prime Intellect framework in the next year, because we have some data that we collect from neurons with our bootloader. And I think it will be a great experience because also we would like to integrate CyberTensor, which we developed as a port of BitTensor stack for their subnets and rewards for different computational tasks. And we would like to integrate CyberTensor to Prime, to training setups, to train models. And let's see, I think it will be interesting experiment for us and Cosmos ecosystem also. And it will be amazing to contribute with Akash on this, because it's, I think it will be great collaboration, compute, algorithms, incentives, and data.
Yeah, there's been quite a lot of demand from the community to bring Akash to BitTensor. I think you're doing incredible work.
Thank you.
So Murthy, I'd love to move on to you. The final piece of our stack that we're building here, what do you see as the current state of AI agents, and how do you think this will evolve over time?
So there's two ways to look at it, Web 2 and Web 3. So Web 2 is far ahead. I think ChatGPT 4.01 is like super duper great. But in terms of Web 3, today I saw a couple of agents for Cosmos community. So they are solving information retrieval. You can ask any question as a developer. It is helping you to figure out very fast. The second thing is they're connecting with wallets. They're connecting with databases, and now they're bringing analytics. Just simply asking questions. Probably you can ask, what is my total portfolio? Your agent will be able to solve that. Yeah, I just presented before in keynote Interchain actions as part of Interchain agent that we built. So this is something, it will take our journey a little bit forward, because you can connect your wallet to the Interchain agent. You can ask your agent to convert your 10 atoms, into Akash tokens when atom hits $10. Probably, it's very tough for us to remember this and do the transaction, but AI agents can do that. This is pretty near. Sometime I feel like, by the time we are on mainnet next year, we will be having this functionality in Interchain AI agent, right? So Interchain agents have two thoughts. Like again, you can integrate that with protocols to kill the functional monolithic. That means when I transact Atom versus Osmosis on Osmosis DEX. So 1,000th time I just do the same thing, but at 1,000th time it should remember me and do something to me. This is what AI agent can. AI agent can do some personalization from protocol side. I think this is not yet started, I feel, but there is more ecosystem UI, UX can be solved with AI agents. So UX side of AI agents or community's integration of AI agent side, where directly talk to chains and have in-chain personalization. I don't think so. We are ready yet. Yeah.
So I think we've covered some of the main pieces of the space, right? Compute, orchestration, training, agents. I'm curious, and just a question for all of you, just to wrap things up and tie it all together. How do you see the tech stack for DAI or decentralized AI evolving over time? You know, we know where it is today. I think we can see a few months, you know, maybe 6 months into the future on where we think it's going to be, but how do you see it changing? Greg, do you want to start?
Yeah, so just to summarize today, right, the trifecta for AI, you have your compute, which is the lifeblood. Without compute, there's no AI. You have the data. Without data, there's no AI. And then you have the model, the code itself, which is actually a small part. It's not a big part, but you do have innovations and models where the creators of the models need to be incentivized to create new models, right? So you have models, you have data, and you have compute. And all three layers need to be decentralized. Compute obviously is the most decentralized aspect of it, and Akash and several other players now. But I don't see data at all being decentralized. I mean, it's a great opportunity for people. There are,
Sentinel is doing, I guess. Who? Sentinel is doing, like they're scraping data in a decentralized fashion.
I mean, I like to see, it's not scraping alone, it's just quality data, it's about labeling, it's about classifying, it's about who can get data from Facebook or who can get data from your phones. I mean, all of us have a lot of data on our phones. So there needs to be a privacy-optimized data retrieval or data extraction stack, which I think is a great opportunity, which I think is going to evolve in the next year or so. There are promising startups like Vana, which is the A16Z funded startup, I think. A bunch of MIT kids figured out how to get into your phones while preserving privacy. I don't know if you want MIT kids sweeping in your phones, but okay, that seems promising. But again, from the model standpoint, I think we are reaching to a point of maturity. BitTensor is a classic example where model creators can incentivize their model creation. So, and also we're seeing interesting new decentralized technologies where can't remember the name of the company, but it's another very promising engineers. They figured out how to fractionalize ownership in a model, in the sense today I have a model, the only way to share the model is to share the code and share the weights, which is the weights are the models. It's effectively free open source. So there's no incentive that goes back to the model creator. In this case, Facebook, for example, spent $100 million in training the model and gave it out for free. And that's not practical for most innovators. So if you can fractionalize the ownership by giving access to the LLM without opening up the weights, I think we have a business model. And folks that contribute to this training of this model, be it whether in compute or cash, can get this fractional ownership. So there could be an NFT that represents the fractional ownership, right? I think that there is a company that's doing this fully decentralized. I'm really excited about it. I'm not going to name what it is because I'm going to invest in this company. but I'm still doing DD. I think it sounds really good. But I think that's going to be some of the stuff that's going to come out in the next few months. I'm really excited about the whole stack. And like we said, 10 billion parameter model is now being trained by Prime Intellect. 100 billion parameter will be a dream. And imagine a trillion parameter model, which
you just want a satellite. I know.
On a satellite, right? Why not? Train complete, and we have the resources. And BitTensor alone is about $4 billion in value. And all of us, if there is a fractional ownership that's solved for training large models, I think we have the compute and we have the resources to do distributed training, and we have the motivation because fractional ownership by the people that use AI, fantastic, right? So we have all the foundational primitives to build a truly decentralized future for AI, and I think all that's missing is interoperability, orchestration, and some degree of leadership to bring all these things together. So if you ask me 6 months and a year from now, sitting on the stage for Cosmoverse 2025, the story will be different. And the story could be, we have a 100 billion parameter model, or it could be a trillion parameter model actually live, and a couple of nuclear reactors under construction too. This is not. This is real. Microsoft bought a nuclear reactor in 3 Mile Island in Pennsylvania. Oracle is building a bunch of nuclear reactors in Texas. These are tech companies buying nuclear reactors, and just picture that, right? If you tell me a tech company is going to buy a nuclear reactor about 20 years ago, I'd be like, dystopian future. But a tech company is buying nuclear reactors to power AI. How dystopian is that?
Crazy.
Dean, I'd love to hear your take.
Well, so the two things I'll add is, right, if you're going to have a heart diagnosis, it better be on legit data, and when you get the diagnosis, you'd better have a trail that it came from the model, that came from these guys against this good data, because when something goes wrong, that's what people need to do in order to debug this stuff, right? So that's really important. The second is that, all of that is on, in some sense, the supply side of AI. The other side is, how do I deploy it such that I can use it? So the frameworks with which we deploy this stuff and deploy it and use it safely, those are mostly not AI. Those are mostly systems engineering kinds of things in order to deploy this stuff into an environment, right? The integration of this into my development process in order to develop things, that's going to happen. That's already happening on an ongoing basis, and that will impact how people build smart contracts and deploy smart contracts. The integration into the testing environment, the integration into the applications that are running decentralized but using off-chain AIs, and how do I have a proof that I use this particular AI to generate this on-chain trading strategy or what have you. All of those are system engineering things into which AI fits, and they will have a lot to do with how reliable, how safe, how extensible our use of AI is in the next 5-10 years.
Valery, how do you see the DAI tech stack evolving?
I see that we will see growing amount of transactions soon, because a lot of agents will come online, built by first not without crypto, but then based on crypto protocols. And the main question that need to be resolved is proofs for inference and proofs for training. Okay, we have collected great data sets. We can launch order from marketplace hardware and launch needed compute. But inference, proofs for inference is the most needed thing, I think, and a lot of research will happen on this field. Same to the training. And as I know, you are also working on this, right?
Yes.
Same question to you. How do you see the DAI tech stack evolving?
Okay. So continuing with this, proof of inference, I think EZK team, that team is working on building ZK proofs for AI, and especially ML techniques. I think they're trying for LLMs. As part of Arka Network's testnet, internal testnet, so we launched the AI competition called Arka Santa. So we used a small VGG model, AI model. We used the EZK-ML verification tool. It was good, but the problem is proof generation was, it is taking so much time. And when we thought of doing this for Interchain AI agent, which is a purpose-built LLM, the problem was, it has tons of layers, right? It's very hard to build a computational graph and verify that. So then we decided, okay, fine. Instead of giving proof of correctness, maybe let's talk about proof of inference. Maybe we can build a computational graph for first two rows, first two layers, and then last two layers. And if we are able to convince that these two, the first two layers and last two layers of LLM is doing right, probably we can, give a partial proof of correctness. Proof of inference is straightforward. I think we can do that. So as part of Arka, we are working on these two streams. Proof of inference it's already in place, but it is taking so much time to serve for real-time users. But proof of correctness is we have to build it. It's a way forward research we have to do. Yeah.
I think that's the perfect place to wrap it up. Thank you so much to all our panelists.